Hello, Cameron. Welcome to the show. Thank you for coming on, man.
Yeah, thanks for having me, Alan. I appreciate it.
Excellent. So we're going to discover what Danomics is. So why don't you start with an intro, telling us who is this for and what the platform is?
Yeah, so Danomics, it is a subsurface interpretation platform built for geologists, reservoir engineers, and petrophysicists. Um, and our real focus has been on building scalable interpretation. So when we first started in the industry, it was before like the unconventional resources boom. And people were used to looking at things, especially on the petrophysics side, one well at a time, or on the geology side, looking at little postage stamps of acreage. And then, once that paradigm kind of changed and people wanted to start doing basin scale analyses, we realized that the workflows that we had didn't scale up in the legacy software. So we decided to write something new, and that's what led us to building Danomics.
Did you actually start as a petrophysical interpretation software and then it evolved into a full modeling package? Is that fair to say?
Yeah, yeah, that's right. That's right. So we started in petrophysics, and you know, so I had used like IP and TechLog and some of the other softwares for years and years, and they're great softwares. You can do a really detailed analysis with them. Um, but like I was saying, like when we decided, instead of looking at one well at a time, we wanted to look at hundreds of wells or thousands of wells, we needed something a bit different. And so we started to redesign the system. And what we quickly realized was, well, if you're going to work with multiple wells, you've got to have some geoscience tools in there, right? So you've got to have maps so you can see where my wells are relative to one another. You've got to, and then people say, hey, we don't want to look at just one well. If we've got all these wells in here, we want to see them in cross section view together. So we then added cross sections into the platform. If you got cross sections in there, people then want to pick tops. Once people have picked their tops, they want to make structure and isopac maps. And so we kept getting pulled more into the geoscience realm. Now, that whole time we were, of course, building up the petrophysics side of the product. That's where all of our early customers was on the petrophysics side. But the petrophysics users kept requesting more geoscience features because they didn't want to have to export results to Petra or Geographics or Petrel or something like that. So, we kept building that side out. And then once we got to the point where we had, structure maps, and, you built out your stratigraphic framework, and you had, and you've got, your interpreted log properties, you can distribute those into a 3D property model, right? So you've got all the ingredients for that. So then we added 3D property models. And at some point, customers were like, hey, we want to see some production in the platform. So we added the ability to import production. And then, of course, what do people ask for? They ask for the ability to decline it out, forecast it, make multi-well type curves. And so that's, what's brought us to where we are today, where we're a pretty broad platform, and we're actually in the process of building seismic in at present.
So I'm just curious, are you positioning yourself as a competitor of this big commercial software, the likes of Petrel? Or are you positioning yourself as, a fast, scalable workflow methodology completely separate from what they do offer?
Well, yeah, I mean, I would obviously love to replace Petrel. I mean, that's kind of a flagship product in the industry. So, I would love for us to get to a point where we could replace Petrel. And we are doing that for some users, depending on what their workflows are. Um, especially if users don't need to go to reservoir simulation, if they're just looking to build that framework, we're, kind of well suited for that. Um, in terms of like really who our competitors are and what we're trying to replace, Kingdom, they're like Kingdom Geology, Geographics, Petra. Those are the competitors on the geology side. Um, and then, we also, of course, compete with the petrophysics packages like IP, TechLog, Geolog. But our goal is to, be an alternative to Petrel, kind of the cloud native, lighter weight,
Hmm.
Petrel like package.
Okay, interesting, interesting. I guess the AI boom is a relatively recent phenomenon, let's say. ChatGPT came 2 years ago or so, 2.5, and still the industry is lagging behind in terms of adoption. But you've been around for much longer. So is the machine learning a key component of the package and the speed and the scalability you were referring to? Is machine learning at the very core of dynamics?
Yeah, it really is. I mean, obviously a lot of petrophysical interpretations are just line by line deterministic type of calculations, right? So if you think about how you would calculate a porosity, let's say you calculate a density porosity, you're just executing a formula line by line, and so it's not very sophisticated type of activity. But where machine learning has really helped is not necessarily with things like that, but with things like washout repair, for example. So let's say your well bore, is a bit washed out, your density curve is bad, and so you need to flag that washout, which machine learning you can play a role in, and then you need to repair it. And if you think about how does a petrophysicist do this manually, the historical way we've done it is you've said, okay, well, maybe I'll try a multilinear regression between, gamma ray neutron and resistivity, and you would make some regression and you'd see how it fits, and then maybe a few years after that, random forest and things like that came along, or neural networks, and you would say, okay, well, let me try and use a neural network or a random forest to do the repair. And it was a very manual process where you would try to do this, on your own, each well at a time, and that obviously doesn't scale. So, an example there is we came up with an automated machine learning approach where the software looks at all your available curves. It makes every combination of model for that well. It does a train test and evaluation on that, and then applies the best fit model, based on your curve availability. So that's an example of how
Yeah,
we've utilized like old fashioned machine learning as a real productivity enhancer, and we've tried to sprinkle it in the platform in a number of different places.
right. And this whole Gen AI, this the last couple of years, what has it meant for you and for Dynamics? What new things have you incorporated um, on account of this recent phenomenon?
Yeah, that's a great question. So obviously when like Chat GPT came out, 2.5, maybe 3 years ago or whatever, it was interesting. You could ask it questions, you could, maybe do a little bit of coding with it, when it first came out, but it wasn't really clear to me what it was going to enable us to do. But as it's matured and as the tooling around it has gotten better, and the cost has came down on running these models, it's really enabled us to do quite a bit. I would say from just kind of from a business perspective, in terms of coding efficiency and things like that, we're actively using all these tools as coding assistants. So it's definitely made our software engineers a lot more productive. But we're also using it in the software in a couple of different ways. Um, and I'll show you one of those ways that we're doing it, which is with our Petrodan AI assistant. If you'd like to
Yeah,
hop over to the
fantastic.
software and take a look at that.
Yeah, you're free
Yeah.
to start with an intro to Dynamics, the platform, and then we can delve deeper into this Gen AI workflow. Um,
Yeah,
just take it
absolutely.
however you see fit, mate.
Yeah, let me share a screen and I'll give you a little bit of background on Danomics because I know a lot of people won't have heard about us yet. Um, so, and let me know if this comes through okay on the screen share. If I need to share it in a different way, I'll happily do that. So,
That's pretty good. Yeah, we can see
okay,
very clear.
yeah. So, really, as I mentioned earlier, our emphasis is on multi-well, petrophysics and geoscience and scalable analyses, and we've been focused on, you know, putting together large scale. And when I say large scale, think about, that could be anywhere from, let's say the Midland or Delaware Basin type of size on down. Um, so, whether or not it's tens, hundreds, or tens of thousands of wells, our software should scale to that. And our goal has been to take users on a journey through geoscience, petrophysics, and to allow you to get to, really a 3D reservoir analysis. And I'll show you some of this in the software as we move on. Now, when I think about our current tool set in Danomics, our two primary products are in geoscience and petrophysics. As we talked about earlier, petrophysics is where we got our start. About 8 years ago, we basically didn't have a line of code to our name. We were going around talking to different companies about, what their needs were. We kind of had a few ideas, but we really got pushed towards multi-well petrophysics. That's where we started. I think we've built out a really robust workflow on the petrophysics side. And like I was saying, when you start doing multi-well petrophysics, that really drags you into the world of geoscience. So we built a lot of tooling around that. Um, and then, now we've started to branch out into seismic. We've also got the production forecasting in there. As I'll show you in a minute, we do have integrated AI assistants in the platform. And from our early feedback on that, some of our customers are really considering that to be kind of a game changer for their analysis. Um, the Now, one of the things that we've learned along the way is you can't be everything to everyone right out of the box. And so the software needs to be customizable. So because of that, we've built in a Python environment. So, you can write your own code in the platform. If you have code from like a data science team that you're running, you can use our infrastructure to feed those models and make predictions. We also completely expose our equation engine to the users. So you can really go in and customize the petrophysics and uh, the economics in the decline curve analysis, to your needs. And one thing that I'm really glad that we did is we made the choice to make it 100% cloud based. Um, if you look at most of the other softwares out there, they're either desktop softwares or they're remote desktops hosted in the cloud. Um, and that presents a lot of challenges, especially when you're trying to grow and you're doing releases all the time. We do something like 70 updates a year, and that just wouldn't be possible with desktop software. But thanks to building it 100% cloud native, that's really accelerated our development.
For sure, for sure.
Yeah. Um, okay. Why is my? There we go. Sorry, jumped a few slides there at once. So on the geoscience side, we've got geoscience packages are all roughly the same, right? Like what is it you want to do in your geoscience package? You want to make maps, you want to make cross sections, you're going to make your structure and isopac grids. Um, so we all have the same basic functionality. But there's been a few things that we've really focused on. One is we want to give the users the displays that they can use to QC their interpretation. So we've added, slice views and 3D views. We've wanted everything to be snappy. And I will say, I think our cross section tool is one of the best in the industry in terms of responsiveness and load times. You can have essentially an infinite scroll cross section in there. So
Hmm.
if you're used to some of the older softwares, you get maybe 40, 50 cross sections on there, and it starts to or wells on your cross section starts to slow to a crawl. We often just start off by throwing 1,000 wells on the cross section, just every well in your project. Uh, and we've recently added a AI assisted tops picking assistant. And that is we I can show you that as well. That has really been you know quite the productivity tool for some of our users. We've had users tell us, well, it doesn't pick 100% of your tops for you, but for major breaks, maybe 70% of them, and for more subtle breaks in the log, maybe it'll pick 30-40% for you.
So that's
So it
interesting there, because so when you say AI assistant, you don't only mean a co-pilot that guides you through what you need to be doing. It actually becomes an agent, an interpretation agent itself, perhaps powered by machine learning underneath. So it's not just a co-pilot.
that's right. It's you pull up the cross section, you activate the tool, and once you pick the first couple of tops, it builds the model and it'll start recommending tops in the next well. And then you can either accept that top or modify it. And if you modify it, it updates the model, and you can start,
Yeah.
and then it'll resume predicting again. Um, so we've tried. Our take on a lot of automation is that it needs to be an assistant
Yeah.
and not fully automated.
Correct.
Um, and the reason for that is if you think about a lot of the historical attempts at automated tops picking, and I've tried this myself, like dozens of different methods and algorithms and whatnot. The problem is if you're trying to automatically pick 1,000 wells, even if you get 90% of it correct right off the bat, then 10% are still wrong. So you have to go find that 10% and go and delete them out and manually pick it, which means that, sure, you start off with 1,000 wells already picked, but then you still have to go through every single one and find the problem. So if you're going to have to do that, then why not just have the tool allow you to go through it faster in the first place?
Yeah, that's right.
Um,
Especially in early adoption stages, users are not going to be accepting blind new tech, especially when it messes up with their own interpretation of things. So they want to have that QCing steps early on.
yeah, exactly. Yeah, users don't like black box technologies. They may tell you they want an easy button that'll do stuff automatically, but as soon as it does stuff automatically, it's like, well, wait a minute, we need to know how it's doing that. So,
Yeah, for sure.
uh,
No, but yes, I mean, I guess this functionality you just described is the one that you have received feedback that it may be a bit of a game changer. It's not like the assistant, the chatbot on the side being your copilot. This is actual, a
yeah,
productivity
it's an
enhancement, big
actual
time. Yeah,
yeah, it's an actual agent that's in there. So, um, and we've got a couple of other agents in here. So, in the Petrophysics, for example, and this will be the first agent that I show you. We have we've put in Petrodan, who's our AI assistant, and on any parameter that you're interpreting, you can ask Dan to run an analysis for that particular parameter, and it'll call the model. It will uh, then make a recommendation on that parameter for you. I'll show you how that works.
yeah.
This one I think is really intriguing, and I actually think that's the way that we're going to see a lot of software go in the not too distant future. Um, you know, and once you've got petrophysics, and once you've got your geoscience done, then you can start building 3D models. Um, and we've done a lot of work with these where you can go in and not just make the model, but you can then pull data out of the model. And we've seen customers using this to let's say they've got a planned horizontal well. They'll go in and they'll extract out a gamma ray from the volume to help with the geosteering. Um, or they have a bunch of horizontal wells and they want to understand the volumetrics of those wells so they can start correlating that to production. So they'll build a porosity model, they'll build a saturation model, they'll extract the data out of that, and they'll use that to calculate a hydrocarbon pore volume or an oil in place. And then they can start doing machine learning using those extracted data and the results from the decline curve analysis. And we actually did an image paper with TGS on that last year. It showed some pretty interesting results on the effects of spacing on wells. Um, yeah, and last slide I'll show here before we move on is we've recently started building in seismic interpretation. This was something that my co-founder wanted to start putting in from day one. He comes from a seismic background, and he's for 7 years was hounding me about, oh, when are we going to get to seismic, when are we going to get to seismic, and we finally made that leap at the end of last year, and we started to build that in. We've added 2D and 3D data loading. We've added 2D and 3D horizon tracking. We're in the process of adding well ties, and once again, this is something that really builds on our petrophysics tools. Um, because obviously you need to go in and clean up your well logs, despike them. Maybe if you're missing, sonic logs in a well, or you're missing a portion of it, you can use some of our machine learning tools to predict that. Um, but this is a kind of an interesting area of development for us, but very early days. We've only been at this for about 4.5, 5 months.
Hmm.
But I think we've made good progress, and I think what our big idea is there is doing well ties at scale. Um, and what I mean by that is, if you look at some of the seismic surveys in the Delaware Basin, the Midland Basin, up in the up in the Western Sedimentary Basin in Canada, what you'll see is that due to the drilling activity, some of these surveys will have hundreds, if not thousands, of wells in them. Um, and we are looking at repurposing our tops picking assistant for doing well ties as well. And so we want to allow you to go into a densely drilled area that has 3D over it and tie hundreds or thousands of wells as part of that, so you can get the best time depth you know conversion possible. So that's our goal there.
Right.
um, yeah. And now I'll spare everyone from seeing any more of my PowerPoint slides here, I promise. So yeah.
Okay,
So
that's
should
good.
we
Yeah, let's jump
yeah.
into it, man.
All right. So I'm just gonna move over to the software here.
Okay.
So here we are in Danomics. A couple things I'll point out. First of all, everything, as you can tell, is coming in through the web browser.
Hmm.
So you don't have to. So you don't have anything to install on your side. You can use any web browser you like. And the good thing is, whether or not you're working from home, the office, a customer office, you're able to get to your files and folders and projects. And when you log in, it takes you to your own custom workspace, just like you're logging into your email. So I know this is a bit different for people. We all always get the question like, "Hey, where's the installer files?" It's like, "Hey, don't
Yeah,
worry about that. Don't need to get IT involved. You can just pull it up and start working."
just log in with your
Um,
credentials and voila.
exactly. Yeah. Just so everyone gets kind of familiar with the petrophysics before I highlight where the AI comes in. Um, we think about our workflow as having three pieces in here, and I'll show you, some areas where we use machine learning in each of these. So the first part is on getting your data ready to work with. So some areas in here, if you think about what are the steps in getting thousands of wells ready to interpret. Well, you need to alias them, because we've got thousands of mnemonics. Um, that's an area where machine learning can obviously plays a role in terms of classifying your different aliases. We also have a built-in alias table of around 10,000 curve mnemonics out of the box there. Um, you need to convert units. You need to, handle the lithological references. Once again, these are areas, especially where generative AI can play a role. If you think about trying to determine if something was logged on a sandstone or limestone matrix, that's a good question that you can ask, an LLM, right? You give it the header information from the LAS file, and it can read that for you and understand the context, and it'll understand like, oh yeah, SSND is sandstone, or DOLM is dolomite. So it can figure those things out and help you make some of those decisions. Um, and then, when it comes to traditional machine learning, I think something like I mentioned with our automated curve repair, where you come in and you flag the washouts, so we can see, hey, we've got a few little washouts here in our area, and I've not done this repair. The software has done it for me, so it's saying, hey, let's look at every possible combination of your data here. Let's look at, gamma ray resistivity neutron, gamma ray resistivity neutron sonic, and so on, in order to build the model to apply this repair that's in here. And here it's called a little washout in the sonic curve, so it's going to, smooth that through for us as well. Um, and the goal of this is, it wasn't to do anything, you know, groundbreaking. I mean, you could do all this manually. It's just, why bother doing it manually? You can't do it manually if you're going to do it 1,000 times, right? You'll just never get through a project. This lets us get through there. Um,
What would have been the human intervention here in the data loading and in this first, washout example you just gave?
yeah. So the human process here, like if I was looking at this and I was doing this in, tech log, let's say, what I would do is I would come here to my cross plot, and I would evaluate, okay, where do I potentially have, washouts in this zone. I would flag them very much like we've done here. I'm flagging it based on caliper, borehole rugosity, density values. So that's what these blocky red bars are here. That's where, we flagged it as bad hole. And then manually, what you would have done is you would have said, okay, well, let me go in and manually make a multilinear regression, let's say, of gamma ray and resistivity to density where it's not washed out. So typically you would have, as the petrophysicist, there's a module in those softwares. You would pop it open, and you would say, training curve 1, training curve 2, target. You'd hit run, you would overlay it in the track, and you would stare at it closely, And then you would say, okay, let me see what happens if I add the sonic in. You'd rerun that. You'd say, okay, well, it looks a little bit better. What if I add the neutron in? Well, I don't think that catches it quite as well. And then you would lock in your model, you'd hit run, and then you'd go to the next well and you'd have to do the same thing. And the next well, maybe you don't have a sonic, so then you're doing something a bit different, so you're not able to just use the same process for every well. Well, so you know what we thought is like, well, computers are really good at automating things. This is my Captain Obvious statement. So we said, all right, well, with a little bit of smart programming, we can just automatically test every combination of model. If you test every combination of model, you can then get a metric on which model is performing the best. So you measure the sum of the squared errors, the root mean squared error, or whatever metric, and then you can apply that. And so it does a couple of things for you. One, on a well with 5 or 6 different curves, it's maybe testing 14 or 15 different models for you automatically. And instead of it being a gut feel, which is a lot of times is what people revert to on when doing things like curve repair, like does this one look good? People, you're actually using a metric to choose which one to apply, so it's quite rigorous in that way. So that's the difference. I mean, it's really the result is the same. Um, it's just the process is different. Like I'm trusting the software to look at you know every model and then return the best one for me.
Yeah. So you just described the conventional approach versus this automated approach, but the human intervention in this automated approach is basically just visually QC the result. That's it.
Yeah, yeah, exactly. I mean, my intervention here would be to say, okay, when I'm looking at my washout flagging, am I being aggressive enough or am I being too aggressive? So I focus less on the model building and more on deciding, hey, where does the model need to be applied,
Yeah.
right? Like I want to come in here and say, okay, yeah, I need to make sure that I'm catching this little washout uh, down here. Need to make sure I'm catching each of these spikes so that I get a repair on that. um, as opposed to
Sure.
concentrating on the model part itself.
So I guess the
um,
user would have the ability to dial up or down a few of knobs, a few of the knobs, and then
Yes. Yeah.
judge. Yeah.
Absolutely. So the controls that we give the user, you can modify any of these parameters zone by zone. So if you want to change how you're evaluating the borehole rugosity or the density cutoffs or D-row cutoffs, you have complete control to come in and say, okay, I want to be a little more aggressive in here. So hey, I can flag that little bit of washout. Now that's obviously you know that's obviously not having much of a difference because that's a pretty small one. But if I said, hey, I want to fix that density spike or that sonic spike there, I can come in and I can tune that in, and I don't have to worry about making the model. I just have to worry about
Yeah.
flagging the washout there, and then you can come along and continue. And the good thing about focusing on flagging washout as opposed to building the model is what we found through working with our customers is that uh, you can often use more of a one size fits all approach. You can say, hey, I know if my borehole rugosity is greater than this, or if my density correction is greater exceeds this value, that the data most likely needs to be repaired. And we find that those values are often constant over an entire play. Whereas the the model and the curve availability, that's something that it needs to be automated because your curve availability is going to change quite a bit from you know from well to well. So you can focus on getting it right once, or focus on getting it right in a small handful of wells, make sure that's internally consistent, and then you can let the machine learning you know kind of run off and do its own thing, knowing that it's evaluating a consistent set of problems.
Is this very process you're describing where the user, focuses on flagging up as opposed to
Hmm.
developing or tuning the model, is this the core of the novelty in the value proposition compared to traditional petrophysical software?
It's I mean it's one small incremental gain. Like there I guess when it comes to productivity and uplift, like often what we've noticed is we'll add in you'll add in a tool that'll save you a little bit of time here, and then you add in another tool and another tool and another tool, and it's the cumulative sum of them
Sure.
that it really adds to that. Like you know for example, another process where we see customers spending a lot of time is just on something like curve normalization,
Yeah,
right? You're looking at you're looking at values across an area. You have different logging companies, different generations of tools, uh, things like that. And if you think about, well, how would the petrophysicist go in and do something like curve normalization? Well, often it would be, oh, I'm going to pull up this well, I'm going to pull up another well, I'm going to, let's say, look at them in a histogram view, and let me, yeah. Um, I'll come in and look at those, in terms of a histogram, and then I'll, maybe do some manual type of alignment, right? Well, we've said, well, is there a better way to do that? Well, you can assign a well to kind of be the blueprint for your analysis, and you can auto align all the means if you're working in a small area, or you can do what I'm doing here, which is we've basically ran a process that's made a grid of the high and low values of our gamma ray. We've used a bit of tooling, some of which uses machine learning to identify outliers and toss those out before we generate those grids. And then we can use that to stretch and squeeze all of our well logs, for example. And what you'll see, and when you do something like that, is most of your well logs experience very little to no normalization. So you'll hardly notice any difference at all. But then as you'll get to a couple of well logs where it is making a big difference, right? So here we can see the original versus the post normalization curve. It's really been stretched out, and we can look at this and say, hey, yep, that's putting it in the correct data ranges. um, and once again, this is a process where you know I don't have to go in and put eyes on all 300 wells in this project or 500 wells in this project. I can you know I build the grids I'm going to use to drive the analysis. I call those once, and then we let the software do the work for us. Knowing that you know that if we do need to go through and QC it all in cross section view and map view, we've got all those tools available for us. So it's really you know this cumulative summation of like, hey, we make normalization easy, we make bad hole repair easy,
yeah.
we try to like make just each little step a few percent easier on the user, and a few percent across 10 different steps. All of a sudden your analysis is significantly enhanced.
For sure. And
Um,
just to be clear, because I think I didn't ask the question correctly. I didn't mean to say that that was the entirety of the value proposition. I wanted to clarify, because I'm not a petrophysicist, I wanted to clarify if these examples you're showing, the washout flagging or the curve
mhm.
normalization, these processes or these workflows you're showing here are novel in the sense that this is not the typical way that it's done in conventional petrophysical workflows. So, and
Y-
they
yeah,
add up,
the
right?
yeah, exactly. The automation piece is what's missing in each of these softwares, right? Like if I was looking at one well in Danomics versus one well in IP or TechLog, my analysis would almost be exactly the same. It's when I start to look at hundreds of wells
Yeah.
where we see a massive divergence in there, right? Because then the automation, becomes compounding. It gives you like this compounding benefit, right? Where, okay, you do it on one well, it saves you a couple minutes. You expand that to a few hundred wells, and it starts saving you hours. In there. And so that's where I think the real advantage is. Um, but let me our workflow is very similar, but let me highlight a couple of areas where I've seen real uplift from using real generative AI
Hmm.
in the platform. So, what I've done here is, let's say I've gone through and I've done my interpretation. I'm ready to calculate volumetrics, and what we're going to do is we're going to use the Vasquez and Beggs and Hall Yarborough correlations to calculate our formation volume factor. Um, Now, to do that, I need to know my oil and gas gravity. Um, Now, if this is an area that I'm really familiar with, I'll just know that number, right? But let's say that maybe that's not in your wheelhouse. It's an area that you're maybe a little bit new to. This is an area where generative AI can really help us. So I'm going to come here, and as I'm hovering over this parameter, I've got this little sparkle icon. I'm going to click that, and it brings up our PetroDan AI assistant. And I'm going to click on Run Analysis here. And what's going on in the background is we're packaging up things like your LAS header information, the well location information, uh, some summary curve statistics, information on your zones, and what it's done is it's ran off and it's ran its analysis. um, Here, and it says, hey, this well is located in Upton County, Texas. It's targeting the Clear Fork, as well as the unconventionals and the Sprayberry and the Wolfcamp. And it's making a series of recommendations for me where it says, hey, for these shallower formations, we're going to use an oil gravity of around 36. But for the deeper formations like the Sprayberry and the Wolfcamp, these typically produce light oil, and a 40 API standard is a typical benchmark for this. And so I have the option here to say, hey, what do I want to take? Do I want to take all of these, some of them, and then I can apply those to my analysis, and that then updates. Um, and so what I like about this is it is a highly targeted uh, application of generative AI, right? So, um, you know, if you think about a lot of times how I don't know how you use generative AI, but a lot of times when I go to it, I use it as kind of a search tool. I'll go to Gemini or Chat GPT, and I'll say, hey, what do you know about this problem? And it'll kind of just runs a search for you. That's similar to what this is doing in the background here. It's going off and it's doing highly targeted search based on the model information, what's available on the internet. We've also given it our help documentation, our equation base, our best practices, um, and it's able to take all of that and say, oh, hey, this is how Danomics is using, this method. Here's the parameters that are important for this method, and then it can go off and do that research and give you, this targeted feedback.
That's interesting. So just let's look under the hood in that very example you showed. So what it
Hmm.
does is it goes out into the world, into the internet, and then retrieves an answer, or do you have your own database sitting underneath? Have you built a RAG pipeline? So what is it that it does behind the scenes when you push that button?
Yeah. So we have not built in like a Danomics proprietary database. I'll circle back to that. So let's put a pin in that for a second. What we've done in terms of giving it, input data is we've given it our help documentation, we've given it our code, our petrophysical code base, and we've given it, instructions on best practices within Danomics. So it knows a lot about Danomics right off the bat. It knows all the parameters that are in the software. It knows how the equations tie together. So it's able to use all that when it's thinking. But the system prompts that are sitting behind it, uh, you know, basically give it instructions that say, hey, we're going to feed you this information about the well. Using that information, you know, look at what you internally know, look at, what is easily accessible via the internet, and then run that search. Now, database tie-ins are a really interesting thing, and we are working with some partners, some operators in this space, to integrate their databases, and in some cases their LLM assistants, their LLM, into the software itself, right? So let's say that you're a Permian Basin focused company. You already have a ton of information about oil and gas gravity, about salinity, about core data. Uh, so you could integrate that into the system prompt and say, hey, go check against these sources, find out what our closest measurement from this interval is for oil and gas gravity, and bring those back. You could put in your company's own best practices. You could say, hey, we don't like using this particular oil correlation. Let's use a different one. Um, so you can really go in there and modify that. When if you find that intriguing, which a growing
Yeah.
number of companies are starting to say, hey, that's you know a really worthwhile exercise.
But pending having your own database against which you do a search, what you're
Hmm.
doing right now is essentially you're putting the prompt out and you're giving a bunch of documentation as context, but it's out
Hmm.
into an external LLM. I don't know, you use a suite of LLMs, or
We're
are you
yeah
married to?
we're using yeah we predominantly use Gemini, to do it. And that's
Yeah,
because, almost all of our stuff is built on Google Cloud.
sure.
So it was just natural for us to use Gemini for that. I think it performs, about as well as any other
Yeah,
uh, model for general oil and gas knowledge. But I think the advantage, or I shouldn't say the advantage. I think, in terms of what the LLM knows is, most of these, big foundational models like Gemini and Claude and, Chat GPT, they've all been trained on massive
yeah,
numbers
absolutely.
of academic papers and things like that. And so, that model has seen thousands of papers on the Midland Basin, right? And so it knows, all the literature from SPE and SEG and AAPG, and so it can go out there and say, hey, I've read all these papers. I know Upton County sprayberry should be light sweet oil. Um,
Yeah.
I think a really good example of this is the other day. It was like it's like late Thursday afternoon. I was uh, I was doing a little bit of work for somebody on some Bakken wells, and uh, and I got to the saturation, and I was like, oh man, what's the salinity in the Bakken? Um, and I was just burnt out, and I thought, well, let me ask Petro Dan. So I went over the salinity module, the water saturation module. Came over here to RW and said, hey, let's oops, clicked the wrong button there. Let's ask Petro Dan what it should be, and Petro Dan came back and say, hey, the Balkan's hypersaline. I don't know what you're doing, but you should use a better RW there, right? So it reminded me that it was 300,000 parts per million. And so you know it it gave me a good answer on that. And this one, here it's saying, hey, yeah, 110,000 parts per million. Let's apply that, and you know, it just kind of gives you a
Yeah.
double check. Even if it gives you a double check. But if you're coming to something cold, like I don't know anything about the salinity up in the Appalachian basins. I've never worked up there. So if I was going to start a project there, I would want to double check, not only using my traditional methods like Pickett plots and RW from SP and stuff like that, but I would use the AI to help
For
guide
sure.
me as well.
So
So it
effectively, you have a Gemini wrapper where you pass the prompt with all the Danomics documentation as context, and then you get the immediate
it
response in app, if you will.
exactly,
Yeah.
yeah. Yeah, and I think the real advantage is that it understands how everything chains together, right? So because it sees our full equation chain, it understands, like I don't know if you noticed just then, but it told me, it said, hey, this, the value you've picked falls within, the data range that you had selected in here in the quick start module for the salinity. Uh, so it was able to recognize, hey, you've already adjusted that value based on this salinity, on this earlier module, that it looks correct for what you've got. So it I think that context of knowing how the software works is really valuable. And
For
I
sure.
do
Yeah.
think I do think at some point we will absolutely have a chat interface hanging, hanging out somewhere here in the bottom right, so you can say, so you can type in more open-ended questions
Yeah.
into it. I think from a help perspective, I think that would be incredibly useful, because we do allow users to write their own equations and parameters and add methods and all sorts of stuff. So I think from that perspective, having the open-ended chat interface would be quite useful. Uh, but then I think for actually setting a, you know, or for even asking it, how should I set the parameters? Because a lot of people, they aren't familiar with, some of these methods, and they don't know that, hey, your endpoint should be, you know, anchored here on the particular matrix point, and how do I set the clay point and stuff like that. So obviously a chat bot could help with that to explain, and the parameter, call it the parameter bot, PetroDan, is much more targeted and knows about that exact parameter.
Yeah.
So I think that's the, when I think about it, that's how I like to think about it. It's like one of them is very targeted and the other is open ended.
That's right. Yeah. And also you have the coding agent or the code copilot, if you will, because Python obviously is a big pillar in your offering here. And if the user is going to be having to write Python stuff, having an in-app Python,
Yes,
agent to help them, that's going to be also a big plus for them.
yes, and yeah, and I definitely think that's another area where we will add some of these capabilities. It's always a trade-off for us because I think you're quite a, I've been looking at your LinkedIn post. I know you're quite experienced with like the AI coding assistants at this point, right? Um, so I think one of the things that we're always trying to balance is like, well, is it worth it for us to, let's say put in the coding assistant now, or is it okay for our customers to, you know, to have,
Mm,
you know, their chat GPT or Claude or whatever and ask it to write the script that they can then copy and paste in. So there's always a trade-off in convenience between,
for sure.
what can our customer what can our customers do in platform versus out of platform, and we always find ourselves asking internally. It's like, well, you know, do we want to completely rewrite Excel, right? Like often, you've got oil and gas data. It's just super easy to go to Excel and manipulate it a little bit before you bring it into the software. So
Exactly.
we're constant. So we constantly ask, like, do we want to recreate Excel? Now it's like, well, do we want to recreate, Claude or Gemini's interface in the software? So, we're constantly having that debate now.
Yeah, I think it's very difficult to navigate at this stage because you don't know what the adoption curve is going to be like. I mean,
Yeah.
yeah, the market is changing so quickly, and the user base is changing, and the literacy in AI is changing. It's still so far behind in the industry. I don't know what you perceive on your end, but
I think I think it's going to be one of those things where it's going to seem like it's changing really slowly, and then all of a sudden, we're going to see adoption just skyrocket, and at that point, there's going to be, the AI haves and have nots,
yeah.
and the companies that are using it and leveraging it in every step of their workflow are going to be just exponentially more productive than those that don't.
Hmm,
Um,
for sure.
so
Okay,
yeah.
Matt, I'm wary of the time here. I've already taken 1 hour of your time. Is there anything else you wanted to showcase?
You know, I know a lot of your audience is reservoir engineers. So we do have a decline curve analysis module. Um, you know, it's not AI powered, but I will give a quick tour of that, and the reason why I want to show this is I think this is it's just a good example of a lightweight tool that you know reservoir engineers can get use out of, but it's also accessible to like the geologists, the petrophysicist, someone working in BD who's not an expert. So just real quick, I'll do this here in like 5 minutes. This is our, essentially our decline curve analysis interface here. We've got, cumulative production bubbles shown here on the map. We can click around from well to well. We've got our decline curve panel up here. If we want to change our declines, we can come in and interact with this on the, on a well by well basis. I accidentally realized that I had hardwired in my water decline there. Um, we can come in, we can build multi-well type curves for oil, gas, and water, and we can run full economics on this to understand things like our IRRs, MPVs, and whatnot. And we can get a full accounting breakdown of this, where we can go from gross production down to net into our net revenues and strip out all our expenses and get an understanding of that. And what I like about this tool, and the reason that we see people using this is just how easy it is to get started. And so what I want to do is I'm just going to really quickly start a new project here. So I'm just going to start a new decline curve analysis. I'll you know just give it a name here, and what I'll show you here is in like 3 minutes how we can decline out a few hundred wells. So I've already got the data loaded, just a Powder River Basin data set. I've got about 7,000 wells, 7,100 wells in this data set. Covers a big chunk of the basin. Now, let's say I wanted to look at Niobrara producers that are from mile long and longer laterals. So what I might do is I say, hey, let's filter out the wells that hardly have any production at all. Let's look at things that have a 4,000 foot or longer lateral length. Let's say that have a spud date after, January 1st of 2014, drilled in the Niobrara formation. And there's, no one ever calls this the same thing. So we've got a few different, names in there. We can turn on our production bubbles. And at this point, every well has been declined out. But there's not really much of a constraint put on there, so we can say, hey, let's constrain our annual declines. Let's not let our B factor get too high. Let's put an exponential decline of, I don't know, maybe 8% on there, and give it a 40-year well life. And we do that, it will have now updated the analysis for all the wells. And we can come in here and we could start QCing this on a well by well basis. Now, here we see a well that's got a really short history, right? Only got a couple of months of production. Well, this is where we'd want to, generate some type curves here. And so, this is down here in that southern cluster. So, if we wanted to make a type curve in here, what I would do is I would just come and select these wells. I'm just going to copy those APIs, come over here to my type curve, and I'm going to make a new, let's call it Niobrara South type curve. And we're gonna add those APIs that we just copied from that polygon in here. And so we'll grab those wells. And once we've done that, we now have we now have an aggregation on there. We're going to look at the P50, and we'll put that on log scale, and we can just come up here and draw our match our type curve here.
Right.
Let's take a look at that background data. Okay, that looks pretty good. We'll now do the same thing for our gas. So let's just come in and we'll drag these values in here. It's off the bottom of the screen. So let me just draw that. Okay. Once again, let's see how many wells are on here. We'll add our well count. Yeah, we're really focused up here where we've got higher well count. Now we've got that type curve. How do we use it? We can just choose that Niobrara South type curve, and now it'll automatically scale itself to the lateral length of this well.
Mm.
So we can we can see how that how that affects things. And now what we need to do is we need to run our economics on this. And to do that, we just come into here and we can turn on our economics, and we can come in here and we can set some global defaults if we want. In terms of oil price, hey, oil price has been pretty good lately, so we'll put that up to $100 a barrel. Gas price, yeah, 280 is probably okay there. We could put, whatever variable OPEX we want for each of these fluids in here. And then now we've got economics for each of our wells. So we've got the IRRs, the pre-drill NPVs, and remaining NPVs. And so that's how you can come in here, decline out a few hundred wells, and get back of the envelope economics in just a couple minutes.
The
Um,
declines were executed on load. You didn't have to
yeah,
do
yeah,
anything.
yeah. It's automatic. I mean, if you think about like the solution, I mean, it's just a. I mean, we're running like a constrained least squares type of solution in there, and even on trying to run it across thousands of wells, uh, you're talking just a few seconds of calculation
Yeah.
time. Um,
Is it
so
a
it,
Python
it's
engine behind for that?
no, for most of our calculations are in Java or C.
Mm,
So the solver, a lot of times like the more calculation heavy stuff, like our solvers are in C, and the other calculations are in Java. And then we'll go to Python for things that we think the user may want to adapt the tool themselves to their own workflow. And we do that in Python because obviously Python's got a much larger user base,
yeah.
so much more user friendly language. Um, so so we'll expose our Python code to the user so the user can copy it, paste it, and modify it to meet their own needs.
Sounds great.
So
And these economics, just to be clear, these are single well economics.
yeah.
Yeah.
Yeah, yeah. For like what it's let me put this on an annual roll up here. Yeah, for this particular well, it's we've got our production profile for each month. Broken, taking the our net revenue interest to get down to our net production, realized prices, revenues, stripping out all the expenses. So this is done on a
Sure.
well by well basis. And then we've got tools that'll aggregate all that for you on the back end.
Right.
So if you're looking at a package of wells, you can go in and export uh, you know each of those wells individually. You can aggregate them. You can aggregate production profiles.
Yeah.
Uh,
For sure. Yeah.
yeah, yeah.
Well,
But
fantastic, man.
you know,
Is there any free trial you offer to the users? I mean, how does this work? If
Yeah, absolutely. There is a free trial. What I'll do is I can show users actually where they can get it from. If you come to our website, Danomics.com, up here on the top right of the menu bar, there's a sign up button. So if you click that, it takes you to a sign up page where you can self register for a trial. This will kick off a 30-day free trial for you. And once you get in the software, you'll be greeted with this welcome page. And this welcome page has a number of tutorials where you can come in and say, hey, I want to learn how to use the Petrophysics, for example. And we've got sample data. It's just public data from the state of Wyoming, both well log header, tops, and production data. And we have a series of video tutorials that will walk the user through everything from loading data through each interpretive module all the way to exporting results. So we've got that for each of the
yeah,
product lines in the software. So users, yeah, just go in and go to once again, that's just uh, Danomics.com and click on the sign up link there to
yeah,
start that free trial.
that's cool. And I noticed those are YouTube embeds, so you run a YouTube channel as well with all the tutorials there.
Yeah, yeah. Danomics has a YouTube channel. We've got hundreds of videos out there now. I'm always surprised that people listen to those, but the stats continue to amaze me in terms of hours of people listening to me BS about petrophysics. So
I think we're 20 minutes past the hour. I really appreciate you coming on and showing us dynamics. I think it's going to catch the attraction of a few. So hopefully we'll be in touch soon, man.
yeah, well, thank you very much for having me on, Alan. I really appreciate the opportunity. So,
Thanks, Dan. Yeah, we'll be in touch. Thank you very much, mate. Have a good day.
all right, thanks. Bye.
Cheers.